Hello guys, how are you doing? Welcome to the rear bumper digital modeling tutorial number 2. Just a quick overview of this tutorial's main points that I think are worth paying attention to. So, in this tutorial you will see what I do in a situation when I don't get a clean theoretical intersection between surfaces. I basically manually created a fillet blend between the surfaces, and I can still achieve a good looking transition with good looking highlights. So, without wasting any precious time, let's jump in and see how I can manage this. Okay, let's see the introduction to the video tutorial from the part 1 again, just to quickly remind ourselves main content from the video. In the first part we created the slab surface number 1, we also created the side surface number 2 and the transition blend 3. Then we created the sill surface number 4 and the tailgate surface 5. Now, if you watched video tutorial 1, you would know that sill surface was probably the most difficult one to create because it was changing its direction from positive to negative. Therefore, we achieved a bubble highlight. In this tutorial, we have yet the most difficult patches to build. These are surfaces 6 and 7. I like to call them the corner surfaces. Maybe they don't look like much of a challenge, but believe me, they really were, as you can see later in this video. To finish off the model, I built surfaces 8 and 9, the blend fillets. I have skipped the process of building surface 8 because it's pretty straightforward. On the other hand though, I paid particular attention to surface 9. The surface 9 was also tricky because I couldn't achieve a proper theoretical intersection between 6 and 7. So I was building surface 9 kind of hanging in the air. As you will see, it wasn't an easy task, but I managed. Okay, so let's just jump right in. It took me a lot of time to model this corner sill. Creating this surface took up most of today's video, mainly because I had two difficulties. The first challenge was to achieve sort of elongation of the highlight of the existing sill surface number 4. Basically, the highlight of our corner blend had to match the existing highlight of the sill surface created in tutorial 1. And also the second challenge was to achieve a decent theoretical intersection. In this place, unfortunately, these two conditions played against each other. When I managed to achieve a good highlight, I lost a good theoretical intersection, and vice versa. All of this had to be achieved taking into consideration the scan data that I couldn't deviate from too much. Normally, I would not deviate from scan data more than 1 mm. However, in this case, as you can see, this part of the scan is of poor quality. Therefore, I had some room for maneuvering. The highlight is not accurate, so we shouldn't refer to it completely. Basically, we could use our artistic eye and sculpt something nice. At the moment, I want to measure the curve to surface distance deviation. I need to untrim this patch, extend the curve on surface, and then trim it back again. The maximum deviation is 0.13 of a millimeter. I'm happy with that. I know that the scan itself also has some inaccuracy. So everything less than, let's say, 0.3 of a millimeter is good by me. At the moment, the highlight is good, the zebra stripe is not too bad. I did a lot of CV movement to optimize each of the CVs. I don't like CVs unnaturally dripping down or standing proud too much. I look from all possible angles to optimize them as soon as possible. There is still some room for improvement available. We can take this opportunity to slide the CVs a little bit more. Okay, I think this looks good enough for the time being. Of course, later on, I still might come across some problems caused by not having the clear theoretical intersection. But at the moment I'm hopeful, and I think that spending any more time on this particular patch will not give us any progress and could be a waste of time. We can create the fillet blend first, and after that evaluate if the patch requires more modifications. At the moment, it's just worth mentioning that the right portion of the patch is actually not intersecting with the top transitional surface. Let's create the fillet blend, marked as surface 9. If you watched my previous video tutorials, by now you might know what I'm going to do to create it. I'm going to take the merge box off and create a quick and roughly extended surface from the fillet of existing geometry that is marked as surface 8. I like to work this way because I can get a perfect connection between the existing fillet and the extended fillet in progress. I can always delete or add some holes to obtain simpler geometry for further modification. At this moment, the situation is pretty bad. I'm thinking how I can make these CVs better. First, I try to rotate holes, then I use hole planarize tool and I hope to get better results. At this stage of freedom modeling, it's important to get just an idea of how the new fillet patch intersects and interacts with geometry around. With time passed and more experienced, you will become more and more spontaneous when coming up with new ideas for CV manipulation. Don't worry too much about any sort of surface continuity at this stage. Just make sure that CVs are neatly distributed within the patch. A good-looking surface can always be aligned later into the process. If you don't get a good CVs layout at this stage, you won't create a decent quality surface and will be wasting your time in later stages of the modeling. Here I'm trying to slide the CVs, but I'm quickly realizing that sliding might not work. I think I'm just going to manually tweak each and every single CV. You can also try to eyeball the distance between the CVs and make everything neat from every view. Later we can add degrees, but at this stage keep it simple, especially the boundary of the patch. I want to rebuild this patch with a square tool. Rebuilding could hopefully give me a better CV layout, especially when applying a rebuild option in a square control window. At this time, I'm not sure about this idea, but I'm very hopeful and keep my fingers crossed. I rebuild curves, create another square, and then try to get better CV flow by modifying the rebuild curves with active history. At this stage, many ideas don't work. In fact, I'm kind of naive trying many different solutions, as I know that they probably won't work anyway. But this is a way I move forward. Trying various ideas give me time to think about other available options. Trying and failing leads me to finding another method that might work just fine. And this is the case in here. I've struggled for quite some time, but finally I find a solution. Only when you exhausted all available options will you know that you probably have to start again. But on the other hand, very often you just get used to the overall picture of the problem, and suddenly, out of nowhere, you come up with a genius idea. At this stage, I know I don't have enough CVs to successfully align the surface, but I'm trying anyway, just to get a good shape for the patch and prepare it for further manipulation. At this stage, I don't worry about any position alignment failures. I just want to get a pleasant looking geometry that is close to, but not necessarily finished. It looks like this patch is shaping up. We are making some progress. Let's examine the geometry with zebra stripes. I think the zebra stripes looks good at the moment. We can try the old trick and extend the left edge with a merge option off. At the moment for you it might look like I just tumbled the view around, but in fact over the years I developed some habits of working. I just moved the view about to give myself more time for figuring out the next step. For now, this extended patch doesn't really look good enough, but again, I'm just playing around to find a better solution. I do some trimming to see how deep this surface dives in. I also estimate gaps values. I'm satisfied with the result. I think in general it's good. I still think that this surface is just too much complicated. Its CVs are not uniform. I will try to build a monorail to simplify the geometry. I think after building a monorail, the surface presents itself much better. I use the trim convert tool and find out that this method is better. Also, the overall CV layout looks much better too. I'm trying to align the patch to the existing geometry. At the same time, I'm reducing number of holes. I normally reduce holes to the absolute minimum. In this case, I only need 2 rows of holes to achieve G2 continuity. Just here. Later, if I needed more control over the patch, I could first delete the align history and then add more holes manually. I can see that some CVs are dipping inside, they would need to be tweaked manually. When I'm modifying these CVs of a second row, I destroy the G2 connection at the bottom of the surface. I'm doing that only because I want to see how the changes affect the adjacent surface. I didn't get much of an improvement. I decided to work on the other side first to take my mind off the difficult bit. Of course you will sooner or later have to solve it anyway, but sometimes you can jump around to solve the easier portions of the model first. This way you will rest your mind and wait for ideas to come around more easily. Now when the surface is shaping up, it's time to add degrees. We would need a 5 degrees surface in order to be able to retain the form and easily position a line to the bottom edge. At this moment, I'm cleaning the topology. I found some misalignment. I'm making sure that corners are aligned. This sometimes may take some time. The ultimate goal is always the same, to optimize patches as much as possible. Let's analyze the tangent break angle in here. It should be consistent and the surface we are working on should be negative. It shouldn't be bulging out, but unfortunately it is at the moment. How to make sure that the tangent break angle is consistent along the edge? Maybe firstly we could forget all the other holes of CVs and only work on the tangency G1 hole. We can first align G0 to the edge and then manually tweak the G1 CVs. Also, at the same time, we could measure the tangent break value, just like I'm doing it right now. By now, we have the first row of CVs pretty much complete. Let's get on with the rest. As you can see, the other CVs also need some working on. But first, let's align all edges to make sure we have G0 continuity around the perimeter. This might cause some temporary position G0 failures, but don't worry, just keep aligning G0 all of relevant edges until you are happy with the result. You just make sure you still have a nice consistent crease. If you need, you can modify the second row of CVs further. Now, I'm just making sure that CVs look good visually. If I see any problems, I simply slide them until everything looks good. The crease created by the consistent tangent break looks alright. There is still some weirdness in this patch, but it's more in the upper area. We are yet to address this problem. Meanwhile, I still need to work on this area. I'm only kind of playing with this right now. I'm trying to align and see what happens. I'm certain that I will lose surface continuity on each side here and here, but it's okay right now. I mainly look at the highlight and CVs. Also, at this point I think of layout strategy. Basically, I think of how to slide the fillet surface to make this transition as easy as possible. Okay, let's delete the cos, the curve on surface, and realign the top edge. Just pay attention to the CVs. They look quite wobbly, but we can easily fix them by being careful and first of all, patiently, manually modify CVs. Let's do the same with the bottom edge. Let's add some degrees. And finally, examine the zebra stripes. Our zebra stripes looks decent. In this area, we still have a continuity problem. Therefore, next we will have to think how to sort it out. A quick recap. The fillet surface was detached and each of the two patches received one span. By doing this, we ensured that we have achieved the G0 continuity by having sufficient number of CVs, and also we don't separate the surfaces into too many small patches. It's easier to work having two patches with one extra span each, rather than having 4 separate surfaces. Later on, when we want to get rid of the spans, we can either try to remove the additional span and realign the surface edge, or just simply detach the surface into 2 patches. But we normally do this at the end of the modeling. So what do you think we can do now to have a smooth G2 connection between fillet and this last patch we are working on? As you can see, there is still a continuity problem. How about detaching this patch and align its edge to the sill edge from the outside? How would you do this in my situation? For now, you can watch me to see how I normally accomplish such modeling. What if we just take this patch and extend it off one corner? We will do the same with the other half. Once this is done, later on we can align both of the extended edges to this outer edge of the sill surface. Now, let's align this left side of the fillet surface to here and at the same time reduce number of CVs to 5. After the alignment, we can see the difference in CV elevation. It looks like we need to slide some CVs down. Otherwise, we will just end up with non-uniformly distributed topology. We will work on that in a minute. Here, we are sliding CVs to get a better layout. There is no rule as to how many CVs should be slid. It's a good practice though to slide 2 or even 3 CVs that sit on the same hull. Optimization in progress. I planarize hulls to make them look better in certain views. I basically apply anything that I have in my sleeve to make them look better. Now I reckon that individual sliding could be better to achieving my goal. In the meantime, I make sure I have a G2 continuity at the top, which was lost by the way when we reduced the number of CVs from 7 to 5 in previous steps. Let's create a sliver of a reference surface right off the sill. This way we have an outside geometry to align our surface to. I just extended the existing surface with the merge box ticked off. By now you should be familiar with this old trick of mine. When aligning G2, I added one extra hole to keep position alignment, otherwise we will have a gap in topology. After I realized We don't really need a G2 continuity in the left portion of the surface. Let's measure the continuity between these two surfaces. In fact, we can freely do some aligning. Now we have lost G2 in this area, but it's okay, it doesn't really matter because it doesn't affect our connection in here. In fact, we still have an extra row to modify if needed. These couple of CV, to be precise. I am making sure to have a G2 connection here. At the same time, I remember I want to keep this nice crease feature. Therefore, I don't want to touch the bottom of this patch. I don't want to modify the G1 row of these CVs. Okay, let's align this surface. We can use this opportunity and reduce its degrees to 5. This surface looks like complete. We can detach this patch and remove the span and move on. Do you like these butt cheeks? How would you get rid of them easily? Maybe we could create a 3 degrees curve. After that, we could align the curve to the existing edge of the fillet surface to make sure it is G2 connected on this side. Then we could simply untrim the sill surface, delete all curves on surface and reproject edges and curves to create new curves on surfaces. Then in the last step, we could align the edges of surfaces to newly built trimmed edges. This method maybe sounds complicated, but in fact it's very easy and works just fine. Here is the complete geometry. Hope you liked the result and I hope you enjoyed the process. I think there's a problem in this area. We basically didn't move any upper CVs of this patch inboard, so this is what we are going to do now. Just behind the scenes, I quickly modified that last patch by pushing hole 3 and 4 slightly inboard. I didn't touch the hole 2 because I didn't want to destroy the elegant crease we created early on. At last, you can see the final result. Some CVs could still benefit from some minor manipulation. However, I think I will just leave it like this for now. I hope you enjoyed the video tutorial and see you next week. Stay tuned.